In today's lesson, we are going to be learning about the number system, and more specifically, the real number system. And we're going to be able to classify numbers within the real number system. So, in that last video that you saw, you hopefully got a good visualization of how to classify numbers and what kind of names they have. In this one, we're going to pretty much do the same thing. That last video had a little bit more technological capabilities than I do, but I'll still walk you guys through this. So in the first one, okay, we're going to use this graphic organizer to determine the sets each number belongs to. So I have this graphic organizer I'm going to share with you right here, all right, and kind of break this down with you, all right. First of all, natural numbers. Natural numbers are all the counting numbers, the ones you can count on your fingers, the ones you can count on your toes, the ones you learned in Sesame Street. All those are good numbers. 1, 2, 3, 4. Okay. Whole numbers are natural numbers along with zero. So 0, 1, 2, 3, 4. Integers are whole numbers, natural numbers, and they're negatives. So -1, -2, -3, -4. Rational numbers are natural numbers, whole numbers, integers. And the root word of rational is ratio. What is a ratio? A ratio is a fraction. So you can write it as a fraction, 2/3, 8/2. And also you can have a repeating decimal, right? 0.11111 repeating, right? Also, a rational number, which is not in this diagram, is a decimal that terminates. For example, 1.5. 1.5 is rational. You could write that as a fraction. 1.5 is 1 and 1/2, or it could be said as 1 and 5/10, or you could write it as a fraction. So a rational number is all of these numbers as well as the ones you can write in fractions. And irrational numbers are ones that you can't write as a fraction. For example, pi, 3.141592 is a long repeating ugly decimal, non-repeating, I should say, it's non-repeating ugly decimal that you can't write as a fraction. Same thing with the square root of 2. The square root of 2 is the opposite. Square root, first of all, is a function that's the opposite of squaring. So the square root of 2 is, let's see, 2 square root button is this long, ugly decimal that doesn't repeat and it doesn't end. So it's irrational. Same thing with 3. Okay, get this long, ugly decimal that doesn't repeat. Yep, it doesn't repeat and doesn't end. All of these numbers are considered real numbers. Any number that you can fit on a calculator pretty much is a real number. Okay, so let's take a look at our problems here. Number 1, we have -6. So -6 is not a natural number, right? You can't count -6 on your fingers and toes and all that good stuff, all right? It's not a whole number, it's not 0, but it's an integer, right? -6 is -1, -2, -3, -4. If I kept going with the trend here, it's -6. And then if it's also an integer, that means it's also a rational number. I can write -6 as a fraction. -6 as a fraction is -6/1. And it's also a real number. So it's an integer, and it's a rational number, and it's real. Okay, the square root of 2, we actually just did that, right? We put that in our calculator, right? Square root of 2 is this long, ugly decimal that doesn't end and doesn't repeat. So it is an irrational number, and it's a real number. So this one, I'm going to do a different color here. So it's going to be irrational, and it's going to be real. All these numbers pretty much are going to be real, all right? Number 7, -2.6, okay? Really, a number doesn't look like that in our diagram, but we know it's a decimal. I can write this as a fraction, right? -2.6, when I write that as a fraction, it's -2 6/10. So if I can write that number as a fraction, that means it is going to be rational. It's not an integer, right? It's a decimal. It doesn't look like any of these numbers. So it's going to be rational and it's going to be real. So this one is rational and real. All right, this one right here, negative square root of 36. If you take a look here, oh, that looks like one of these. It has to be irrational, right? Not so fast. Square root of 36. If I put that in the calculator, now be careful. Don't put in negative square root of 36 because watch, we'll see what happens when I put in negative. 36, negative, and then the square root button, okay, you'll get something that looks like this. So you have to do the square root of 36 first. 36 square root button, which is 6. So this is actually the number -6. That's what this is actually equal to. And we already did that, right? Didn't we do that up here? It's an integer and it's rational and it's real. So this one and this one are exactly the same, right? They're integers and they're rational and they're real. All right. And then now for this one, -3.759, I can write that as a fraction. Where are we at here? There it is. So I can write this as a fraction, right? -3.759. I can write that as -3 and 759 over 1,000, right? That's how I write this as a fraction. So that means this is going to be rational, right? If I look at my diagram, it's going to be rational. It's not an integer, right? Nothing looks, not a whole number, it's not natural. It's going to be rational and it's going to be real. All right, so the calculator is an awesome tool on being able to tell what kind of numbers these are. So you're going to put these in, some of these in the calculator and be able to determine what kind of numbers they are using the graphic organizer here. And just don't assume, like this one, we assume that, oh, the square root has to be irrational. No, okay, try putting the calculator first to determine which type of number it is. All right, so go ahead and go through these problems and determine what kind of numbers they are. And feel free to ask me questions and good luck. Thank you for watching.